code. So in Player Maker, which is the code to make our player dude, let's go ahead and zoom in a little bit here. We got a bunch of stuff. This is, I won't go through all of it, but it's a module just like always. Public, table, do the requires we need. I talked about the base walking angle on a previous show, but this is a table that basically lets us choose the angle at which we're going to be moving based on the animation that we're playing, so north, northeast, east, etc. Because we lock our player. Did I do this? Am I doing this right? Here. I set this all up, and then I'm not doing what I said I was going to do, so let's do it right. I set this up with code so that we could pause it, and I could show you the code on the side. So on the side here, we lock our player in. Let me reload him and walk him around. You can see he only moves at fixed angles. So basically every 45-degree angles he can walk in that direction. He doesn't walk omnidirectionally. And stop. So that's where this is coming in. Then we'll do some localizations to get some speed up. So we get math random, we put it in a variable here. So if I call that a lot, it's going to be a little bit faster. One I use a lot is pairs, so I use localized pairs. We have the destroy function, which is called when we restart the game or we want to load a new level. And this basically destroys the player. It stops listening for the enter frame, mouse, and key events, and then we clear it. And we also get rid of all our arrows that are being counted. Then there's the create function, which we talked about previously. We pass in the reticle, which is this little bugger right here. And we use this to determine the facing direction of our player. So we create the player, we add the body, we set up some variables such as the angle it's facing at, and we keep it in a different variable from rotation because we're not going to rotate it again. We're going to just keep track of the angle and play the correct animation. It's always rotated at 0, so never set to anything else. We set the base rate of movement. So if you wanted to experiment in this game, I could have put this in common, and I probably should have. But if you want to experiment with different move rates, you can change this here. We're only going to allow the character to move forward. So move Y is keeping track of whether or not the forward button is pressed, which is W or the up arrow key. I think I did both. Let me check. Yes. So as long as you are, basically what it does, oops, what's going on there? Basically what it does is moves in the direction, it's freaking out. All right, stop freaking out. So moves in the direction you are facing. So we keep track of that in this variable. We'll get to it in a minute. And for today's talk, we have a new variable called isFiring. So isFiring keeps track of whether or not we have done whatever it is we're supposed to do to tell the player to fire. Now, in this game, the way we tell the player to fire is we press the left mouse button. So the reticle, the reticle here tracks the position of the mouse. And when we click, what we want to do is we want to have the player play an animation and then produce an arrow and fling that arrow off in the direction that it's currently facing. So we'll get to that code in just a moment. When we're creating the player, we have the current facing angle, so we play the correct animation based on that angle. And our current animation is paused when we start, but later on that'll be walking. So we're paused facing at 0. That's paused, and for whatever reason it's facing down, but we'll just leave that alone for now. Okay, so movement was via the key input, and it was very simple. We looked at this previously, last week or the week before, but it's the W key or the up key, and then assuming that we are pressing that key down, we set the move Y to -1. Otherwise, we set move Y to 0. So a -1 value says move forward, which we'll use later in our enter frame. And our enter frame will do a number of things. It will face the reticle, and then it will check to see if move y is less than 0, which means that we are supposed to be moving forward. And I won't go through all this code, but the essence of it is calculate the angle we're supposed to be facing, play the correct animation, and change the velocity of the player to be moving at the correct rate in that direction. But you saw me zip by today's code, and today's code is the mouse code. So, way down here on line 107, and just as a warning to people, this code for the player, I said it previously, it's very complicated compared to the rest of the game. It's probably the most complicated piece of code, and so it grows and grows and grows. So when you're first starting out, by all means, you should be looking at the other bits of code and then work your way up to looking at the player code. But just be aware that it's going to be a long piece of code and semi-complicated. One of the things that I have added to the player for this week is a function called mouse. Now, there is an event called mouse, which I listen for, and I use the listen function, which I wrote in Common. Let me show it to you, which is a piece of code that I stole out of SSK, but I so love it that I did not want to use the runtime equivalent. So let me show it to you instead. Just type, this would super be awesome. Okay, so there are 3 runtime functions that you can use to set up arbitrary listeners. Now, an arbitrary listener is a listener that is listening for an event that has a name that may or may not be one of the standard events. So a standard event is mouse, touch, collision, pre-collision. Those are all standard named events that Corona defines. However, the beautiful thing about Corona and Lua is that you can create, well, in Lua it's a little bit different, but the beautiful thing about Corona is you can create arbitrary events that your objects will listen for and then do something when they get those events. So on press or on key or on player died. I mean, you can just make up all these nice event names and then do something when that event occurs. So there are 3 functions that let us do this. There's the runtime add event listener, the runtime remove event listener, which people should be familiar with because they use them all the time, or should be using them pretty much all the time. But there's another one here called dispatch event. Now, a lot of people don't use this. I don't think a lot of people use it, and they should become aware of it. What runtime dispatch event does is it injects a named event into the Corona event cycle, event tree. And it's what's called a global event. A runtime event is a global event. It can be seen by all objects, all scripts, everywhere. And so you can create listeners that are global listeners, or you can create listeners that are attached to objects. So for example, let's say you had smart zombies and dumb zombies, and you wanted the smart zombies to chase the player, but you wanted the dumb zombies to just like wander around. So you could add a function on the smart zombies called dinner bell. Let's just call it dinner bell. And every time the player moved, you would cast an event called dinner bell. You would dispatch the event dinner bell, and then that code would run on each zombie that had the dinner bell listener and do something smart, like aim at the player and walk in the direction of the player. Whereas the dumb zombies, not having this event listener, very funny. Steve asks, do the dumb zombies try to eat the smart one's brains? Maybe, I don't know. Whereas the dumb zombies not having this listener would not do anything. So I use this all the time in my code. It's I could not get by coding without the ability to add listeners to my various display objects, etc. And the reason is I like to keep my code very disconnected. Let's say, for example, I want to have a HUD, heads-up display. It's like a score counter. I don't want the score counter to have to know about the player or have to know about all the different elements in the game. What I would prefer to do is have a player that can do something that gets it a score and simply dispatch a score increase event and have the HUD listening for that and say, oh, the score increased. I don't know who did it. I don't know about the player. I don't know about the enemies. I just know about me, and I'm listening for this one event. I'll increment the score by whatever this event tells me to. Now, I know I'm going on and on here, but I really want people to understand that this is very important, and we have used this. If you go back into the previous shows, we have used this for all of our previous score counters and things like that, and maybe it was subtle or I kind of glossed over it, but this basic concept gets used over and over again in this series, and so if you haven't learned how to do it, you can walk back into the previous games and look at the episodes where I talk about the score counters. That'll be a good starting point to understand this.